Confused. A lot of you had the right idea. You did it back to how we would have done it in secondary 2, but now we're in secondary 3. So it's a right triangle. We can use right triangle trig. So you set up your trig ratio. Opposite and hypotenuse gives a sine. I saw all of you got this. Sine of 60 is equal to x over 10, right? So x is equal to 10 sine of 60. Now, a lot of us thought at this point, let's just type it into our calculator. However, that's only an acceptable thing to do really in secondary math 2. In secondary 3, we learned the unit circle. We know that 60 degrees has an xy point, right? Which is 1/2 root 3 over 2. So sine is y, correct? So we know, because this is a special right triangle, that the sine of 60 is equal to, the exact value is square root of 3 over 2. So sine of 60 is root 3 over 2. So does everybody see how this is an exact answer? So x is equal to, I knew that most of you got it there. 5 root 3. 10 and 2 divide out, right? Okay, awesome. So just a reminder that if it's ever a special angle, I would expect an exact answer. If it wasn't a special angle, then you would just go ahead and use your calculator. Yeah. Okay. Couple things before we. Okay, so to make this lesson go smooth, you all have to agree to have your calculators out, ready to calculate things very quickly for me. It'll go smooth and quick, and I'll give you time at the end to work on homework. It goes grandma slow if nobody is ready to go. But that means everybody. Don't just count on the person next to you. We've been dealing with all right triangles, solving missing angles, and solving missing sides of right triangles. However, there are many other types of triangles that can be created that are non-right triangles. So once again, like I said, so far we've been dealing with right triangles and using right triangle trig. However, if it's a non-right triangle, it is not allowed to use right triangle trig. In fact, there was a student of mine that was going to an ACT test prep class after this lesson in secondary 3 regular last year, and she had a teacher that didn't teach math, teaching the ACT test prep class. And they came upon a triangle, and the teacher said, oh, I can do this one. And she was helping with math, and she did Pythagorean theorem, and it was a non-right triangle. And that girl was like, yikes. That's not how you do that. And the teacher's like, yes, it is. And then I had to go talk to the teacher. Okay, she's teaching them wrong. So if it's non-right triangle, you have to still be able to solve missing angles and missing sides. So just a quick word for you. A non-right triangle is called an oblique triangle. So if there's not a 90-degree angle, then it's called an oblique triangle. So a couple things to note for notation is A, angles will be in capital letters, angle A, C, B, and side, the side across from angle A is side A, will be written with a little a. Across from side angle C is side C, across from angle B is side B, written with a little letter. Okay, so to solve an oblique triangle, this is one thing you do have to have. So to solve an oblique triangle, we must have at least one side and then any two other parts. So at least one side and then any two other parts will work, and then we can solve it. So today we're going to focus on using the law of sines to solve, and this is when you'll use the law of sines. So in triangle ABC, if we have two angles, if we're given two angles on any side, we can use the law of sines. So look, two angles means we can find the third angle, right? I could find that, right? So given two angles, I could find that angle, right, everybody? So given two angles and any other side, you can use the law of sines to solve. So just notice, if I didn't put that green mark there, if we were given the blue and the red thing, that would be in the order of angle, side, angle, right, everybody? But the rule is, if you're given two angles and any side, you can use the law of sines. Now, just a note, this is angle, angle, side. So, yeah, just a side note. Doesn't really matter. Two angles and a side, you can use the law of sines. Now, that's because you can find the third angle. Now, also, we'll use the law of sines if we have two sides and an angle opposite of one of the sides. So I like to say that backwards. Given an angle and two sides where one of the sides is definitely across from the given angle. So this would not work if I move those blue lines up here. Do you see how it is not an angle that is across from a given side? So it has to be, to use the law of sines, it has to be an angle and then two other sides, and the side across, we have to be given a side across from the angle. Otherwise, we'll use the law of cosines, which we'll learn next time. Now I'm going to tell you what the law of sines is. Now understand, like, you don't have to really memorize this, because once you see how the law of sines works, A lot of times what will happen is you don't even have to memorize it. You'll go to use the law of sines and you'll say, oh, I can't. And then you'll just you'll do the law of cosines. Does that make sense? So don't get too caught up in this. Once you see how the law of sines works, it makes sense of when you can and can't use it. Does that make sense, everybody? A little bit? Okay. So here is the law of sines, and then in a second I'll show you, remind you of where it comes from. So given this triangle, these ratios are true. So sine of angle A over side A will be equal to the ratio of sine of angle B over side B. Will be equal to sine of angle C over side C. So that also is true for the reciprocal. A over sine of angle A will be equal to the ratio of side B over sine of side B. Over sine of angle B will be equal to the ratio of C over sine of angle C. So I just want you to notice something, guys. The ratios are set up sine of the angle divided by the side across from it. That easy. All those ratios will be true. So sine of that angle divided by that side will be equal to the sine of that angle divided by that side will be equal to the sine of that angle divided by that side. Just that easy. Does that make sense, everybody? And we can put whichever one we want on top. So here's what a few students, I learned a few things from teaching this the past few hours. People are saying, which one should I use, this one or this one? It doesn't matter whatsoever. However, it makes it easier to solve algebraically if you put what you're trying to solve for on top. So let's say we were trying to find angle A. It'd just be easier algebra to put sine of A on top, because that would be what we're trying to solve for. However, if we're trying to solve for side A, it's easier to just put it on top, just because the algebra works out prettier. Okay, so this is where the law of sines comes from and why does it work. So you guys should have explored this in secondary too. We just don't have time. I'm going to show you why it works. And then you'll see, oh yeah, that does make sense. I wish I could have you explore it and stuff, but we just don't have the time. So you should have explored it in secondary too. So if I go down and drop an altitude or a height, I'm going to call it a height, that creates a 90-degree angle, correct? If I drop it at a 90-degree angle. So don't we have two different right triangles? 1 and 2. So watch this. So let's focus on this right triangle here. Let's put theta here, but we're going to call it angle A instead of theta. So isn't it true that I could set up, since it's a right triangle trig, opposite and hypotenuse is sine, right? So we would say sine of angle A equals opposite, which is H, over hypotenuse, which is B. Does everybody agree? Okay, let's look at this right triangle here. So theta is here, opposite and hypotenuse would be our sine. So it's true to say sine of angle B equals H over A. Does everybody see how I set up those two right triangle trig ratios? Okay, now let's solve for H. So multiply both sides by B. So, sorry, I keep sneezing. Like this time of year is the worst. H is equal to B sine of A, like I'm about to sneeze, so that's why I said that, like I didn't sneeze yet. But, okay. Multiply both sides by A. So isn't this H and this H the same? Wasn't it the same height, guys? So H is also equal to A sine of B. Okay, so guys, if their heights are equal, aren't they equal? So isn't this statement equal to that statement? So we would say B sine of A equals A sine of B. Now let's get like things on the same side of the equation. So instead of having A sine of B, let's get all the A's on one side, all the B's on the other side. So how would I undo A? Divide both sides by A, right? A's divide out. Let's get rid of this B, so we would divide both sides by B, right? So then B divides out. So if this was true, then this was true. So then sine of angle A over A, we just did the algebra, do you see it? Equals sine of angle B over side B. Does everybody see how that works? Okay, so that's where the law of sines comes from. Okay, so let's go ahead and use the law of sines. So if you want to draw this picture in, a couple things, let me just read you what this says, because I have so many people not be able to read it. So this angle is 102.3 degrees. This angle is 28.7 degrees. I just drew in a double line, that's not a 9. 28.7 degrees. Okay, so let's go find all the missing parts. This is where you're all going to have a calculator handy, ready to go. So this is angle A, this is side A, this is angle C, let's call this side C, and then obviously this is angle A. Now let's see why we would use the law of sines. We're given two angles and one side, correct? We're going to use the law of sines because we can easily find this other angle here. So let's find angle A first of all. You would take 180 degrees minus 28.7 minus 102.3. Everybody, what do we get? Angle A is equal to, I got 49. Okay, 49 degrees. So that is 49 degrees. Does everybody agree? Now, look, we can go ahead and find side A by setting up the law of sines. So, it is true. Let's focus on finding side A. So, let's put that on top. So, A over sine of angle A, which is 49, is going to be equal to, well, let's use this angle since we were given that side. Everybody good? So that side, 27.4 over sine of the angle across from it. Sine of 28.7. Now, all you have to do is use algebra to solve for A and get A alone. With just algebra, now we set up a true statement. So what if we, to get A alone, multiply both sides by sine of 49? Okay, let's do that. Multiply by sine of 49 to both sides. So side A is equal to 27.4 divided by sine of 28.7 times sine of 49. I want you all to type it in so that we can all get the same answer and know we're all good. Okay, perfect. Everybody else? Okay, then I believe you. 43.06. 06. So let's round the same as they did. It looks like they rounded one decimal place. So A, let's go back. I'm just going to put it in the right spot. 46.1. Wait, 43.1. Sorry. 43.1. Okay, now, could we use Pythagorean theorem? No, right? Because it's not a right triangle, right? So it's okay. That's what I just wanted to make sure of. Is we would then from there still not use right triangle Pythagorean theorem. So we're gonna set up the law of sines again. So let's find side C. So C over sine of angle across from it, 102.3 equals, we could use anything else, either one. I'm just gonna go with this again. Equals 27.4 over sine of 28.7, right? Now to solve for C, we would multiply both sides by sine of 102.3. Okay, you got side C was what? 55.7. Did we all get that? Yep. Okay, let's see if our triangle makes sense, because it should. The largest angle should be across from the largest side, yes? Medium angle is across from the medium length side. And then smallest angle is across from the smallest side. So our triangle makes sense, so we probably did it right. If something doesn't make sense, we've done something wrong. Okay, next thing, you're going to be asked to draw your own pictures. So just look at this one and then see how I make sense of how to draw. It says, a pole tilts toward the sun at an 8-degree angle away from the vertical and casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So if this is my vertical and it's tilted 8 degrees away from the vertical, this is 90, just from there to there, right? So if I drew in my new triangle, what I'm really looking at a little bit more like that, this is going to be what angle? 98 degrees. So it's a non-right triangle. This is 43 and this is 22. It wants to know how tall is the pole, so I'm going to put X there. So we would need to use the law of sines because we're given two angles and another side. So we can easily find that angle. So everybody find that angle. We're going to need it. 180 minus 98 minus 43. 39 degrees. So now, what am I solving for? X. So let's start with that. X over sine of the angle across from it, which is 43, equals, we're going to use, since we have this side, that angle, that's why I had to find it. So equals 22 divided by sine of 39. And now it's just algebra to get x alone. So x is going to be equal to 22. Wait, not to do this. Sine of 39 times sine of 43. 23.8. Okay, cool. 23.8 feet is how tall it is. Okay, find the missing sides and angles. Let's go quick through this one. We're using the law of sines. Now look at it. We're given an angle and two sides. Is one of the sides across from the given angle? Okay, so we're good. Otherwise, we couldn't. So it says find the missing angle. So won't we first be finding angle B? Because we're given that side. So we'd say B over sine of, sorry, not B. Let's put what we don't know on, oh yeah, I like what you're saying. Put sine of B on top since that's what we're trying to find. Okay, watch, this one's different algebraically. Sine of B over 12 equals sine of 42 over 22. Okay, now we're solving for B, so you've got to use algebra to get B alone. First step is to, good, multiply both sides by 12. 12 divides out. I'm going to show my work. Sine of B equals that. Now what would we do? B is trapped inside sine. Good, sine inverse of both sides of the equation. So now inverse and sine cancel out. We're at B is equal to sine inverse of all that stuff. So 12, sine of 42, all over 22. So you'll type in your calculator. I want you all typing it in. Second sine of all that stuff. 21.4. Okay, cool. Now it's easy to find angle C, right? Okay, well. No, but you might see this answer, so it's good to have it written out because they might, on a multiple choice test, just put that. Good questions. Good questions. So it never hurts to see it written like that. Okay, so now to find angle C, you do 180 minus that. Go. 116.6. Okay, now let's find side C. So we'll have to set up C over sine of 116.6 equals, either one will work. I'm just going to go with 42. Equals 22 over sine of 42. So then C is going to be that times that. Go. Right, we would multiply that up. Oh, we found the angle? Yep, perfect. Okay, perfect. And our triangle makes sense. The largest sides across from the largest angle and so on and so forth. Okay, now we're to our exploring. Don't look. Okay, what I want you to do while I cover this up is we're going to talk about the times when we've been using the law of sines when this happens. So everybody listening. So we're going to get to the ambiguous case for the law of sines. So sometimes our pictures can be deceiving. The question is, can you even make a triangle? If so, how many triangles can we make? So that's the real question, guys. Given the information, can you even make a triangle with that information? Can you make multiple triangles or one triangle? That's our question. So, everybody, for example, if we're given angle A and two sides, we said that as long as the side across from it, the given angle, we're given the side across from the given angle, right? That's when could we use the, sorry, I didn't mean to do that. So we can use the law of sines when we're given an angle and two sides as long as one of the sides across from it is given, correct? Now here's the thing, guys. We've got to think about what could happen when dealing with something like this. So what I want you to do, you have your picture drawn. This is what your string looks like, correct? You have it taped here. You have it taped over here to not move, correct? And then you have it taped somewhere right here. Okay, so what I want you to do is, notice, I could drop down, and you could do this with your X-fill marker. Grab an X-fill marker, and from the tip up here that you have taped down, I want you to draw in a height. Boom, boom, boom. Okay. Now what I want you to do is, because I had you tape that, this tape is going to be called the movable tape. So if I say take your movable tape and move it, that means that can actually move. Okay, so for right now. So what I want you to do is we're going to look at case 1 and you're going to tell me what could happen. How many triangles? If so, how many? Couple rules. Couple rules. To make a true triangle, your string has to touch exactly. Does that make sense? You cannot call this a triangle, for example. That's an extra string, right? Has to touch perfectly. Does everybody understand the rules? This angle, once you tape it, then you can't, the only thing you can move is this is going to be our swinging side. So look at my board over here. This is my swinging side. Okay, here we go. So what I want you to do is physically make, we're going to call this our height. You're going to make side A smaller than side B. Physically make side A smaller than side B, and it has to be smaller than the height. So everybody look over here. I'm going to move this. Everybody, are you watching? Okay, so I've got to go ahead and go up here and make some triangle where we're going to call this side B. So label it on your desk. This is side B. So think about it. Won't this be side A, guys, since it's across from angle A? Look, angle A, so across this side A. Okay, you are now doing case 1. So you're making this length A smaller than the height. Do you see how mine is now smaller than the height? Look at it. You've got to make your string smaller than the height for A and also smaller than B. You see how I've drawn my picture accordingly? Yeah. I've made my string the correct. So I want you to explore and tell me how many triangles, when we run into where A is smaller than the height and smaller than B, how many triangles exist here? Ready, go. Talk as a group. You've got to make your triangle. The only way it happens if it connects perfectly. You can't do anything else. You can't extend it. We're making perfect triangles here. Those cases have to be true. So the answer is no such triangle can be formed. So look, guys, my picture right here, my A is shorter than H. Oops. My A, so my string should be shorter than H. There it is. And shorter than H and shorter than B. Won't this string just never connect and never be able to make a triangle here? Like literally the side's not long enough to come down and connect. Does everybody understand? So if A is less than B, shorter than B, and shorter than the height, there's no such triangle. No triangle exists. Okay. Next case. We're focusing in on next case. If A equals the height. So if your string, you got to go down and draw on your string, make sure that they're the same length. You get what I'm saying, right? So physically go over and make your string height and A the same length. You're going to have to move the movable tape. You're going to have to move your movable tape so that you can move and make sure that this and this are the same length, right? Then tell me how many triangles. Okay, you guys are awesome. You said one right triangle, which is true. So if A happens to be the same as the height, you guys, you could use the law of sines, but you could also use right triangle string, which is easier, kind of, just because we practiced it more. Okay, what I want you to do is, if each of these things happen, so you're going to test them individually. So make A greater than B, quite a bit greater, like go quite a bit bigger than B. And then also see what happens if A is the same length as B. So you're going to move your string and connect. Make sure that this side A is the same length as side B. So go to B, you know what I mean? Take your movable tape and move it and make sure that that length is the same as that length. See how many triangles exist. If A is greater than B, how many triangles exist? And if A is equal, because this means greater than or equal to B. So I'll also do A is equal to B. So let's say that A is the physical same length as B. A lot of you were able to draw that out correctly. You measured your string, and then you extended that so that this and this are the same length. So when you swung it, didn't it touch right there? Making one exact triangle. Now if A was much longer than B, let's make it much longer. You had to put it more out here, correct? Making one triangle. And then once it came around, when it equaled B, when it came around, didn't it just cross through perfectly there? Okay, so there was only one triangle, right? And if it's much larger than B, it came and it passed it, right? Didn't it pass it and never create? So if A is much larger than B, then, or if A is larger than or equal to B, there's just one triangle. So that makes sense because remember back in secondary 2, they only gave you examples where that happened. So right here was an example. So I was given an angle and two sides, right? Isn't this side across larger than this side? So it's going to wrap and it's only going to touch that exact spot once and pass it again. So it's only that one triangle we're dealing with. Okay, last case. This is the most important case. So move your tape where A is larger than the height. So A is going to be longer than your height. It does have to be longer than your height. So go down, make sure that A is larger than the height. But it also has to be smaller than B. So retape it in the correct spot where it's going to be smaller than side B, less than B, but longer than the height. Why? The correct answer was 2. I did not mean to put up 2 triangles. I don't know why I was doing it. So, 2 triangles exist. So here's why. Everybody look over here at the whiteboard. I have drawn this correctly. The condition has to be met where it's shorter than B, but longer than my height, right? So as it comes down, boom, it touches perfectly there. I need to look. It comes down and touches perfectly there. So we would have this triangle that looks something like that, correct? Let's label it correctly. A, side B, so what's this angle? B, side C. Angle C, side C, side A. Okay. Now also, it's swinging still. Okay, now it's overlapping. Not a triangle, not a triangle, not a triangle. Uh-oh, boom. We have another triangle that's been created. So now let's draw in this new looking triangle here. So that was A, B. This is still side B, right? Right? So this is still angle B. So this is C, C, A. So we have 2 triangles that happen when that happens. So what happens is, I'm going to scroll up and give myself some room, is what's happening is this. So it's coming down, and because it's longer than the height, it's swooping and crossing there, creating that triangle. Then it's swooping, and because it's smaller than B, it's crossing there again. So now we have this other triangle. So do you see how we have an acute angle B and an obtuse angle B? Okay, so we have 2 triangles where one of them B is acute and one of them B is obtuse. Look at my pictures. Acute, obtuse. So we have to do both triangles. We have to solve both when that happens. Pretty cool. Okay. Here we go. So it says, does the triangle exist? If so, find the missing sides. So everybody, let's draw in what we have here. So I'm going to call this angle A, draw this in side A. So side A is 12, correct? Across from angle A, which is angle A is 20.5. Now side B, let's call this side B is 31. So let's see, we would be using the law of sines here because we're given an angle and 2 sides, or one of the sides across is across from the given angle, right? Now we need to check. Is this side going to extend and is it going to go like this and never cross because it's shorter than our height, right? Or is it going to come down and cross twice? Or is it going to, you know what I mean? We know. Yeah. So let's figure out this. We've got to figure out the height first. So we have a right triangle, and we're going to go opposite and hypotenuse, which is sine. So sine of 20.5 equals opposite over hypotenuse. So let's solve for our height so we know how many times this is going to cross. 31 sine of 20.5 equals my height. What is it? 10.9. So this length right here is 10.9, guys. So let's draw a little bit more to scale. So that's longer, right? So is it going to cross once, cross twice? Because this is 31. So we've got to draw in what we have. We have an acute one for angle B. Let's call this angle B because it's across from side B is acute. And we also, if I'm drawing this in and not getting ahead of myself. Right? So I'm going to call this C. We also have this triangle right here, where this was 31 still, right? This is angle A, angle B, and angle C here. This side is still 12. I didn't draw that perfectly, but that's okay. And then this is an obtuse angle, correct? Okay, so let's solve the triangle. So we have two triangles to solve here. So first of all, I'm just going to start and look and see. Let's find angle B first. So let's find angle B. Let's figure out, we'll see which angle we're finding, the acute one or the obtuse one. So let's set up the law of sines. So what do we say? We're trying to find angle B. So sine of B over the side across from it equals sine of 20.5 divided by 12. So now it's just solving for B using algebra. So we have sine of B equals 31 sine of 20.5. I'm multiplying both sides by 31. And then what we take the inverse. So B, angle B will be sine inverse of all that stuff. What's angle B? We should all be typing it in. Remember, this is one of those times when people just start waiting for everybody else to do it and it takes us forever. 64.78, so 64.8. Is that an acute angle or an obtuse? It's acute. Now, understand, so that's going to go right here, 64.8. That is always, if we type into our calculator sine inverse of something, it's always going to give us the acute answer. Why? Because remember back to sine inverse. I'm going to draw it. Sine inverse has an input, has an output between positive pi halves and negative pi halves, right? So won't our outputs always be acute here? You get what I'm saying? Yeah, it's not going to be, it's never, your calculator is never going to give you an output over here. But we do have this obtuse angle. So how would we find this obtuse angle? Okay guys, this is one of those times where you're not focusing and there's too much silliness going on and whatnot. So how would we find the obtuse angle? So we know the acute angle was, for example, the acute angle was 64.8. So couldn't I go and draw a triangle with an acute angle of 64.8? That's a triangle, correct? Now that has an XY point right here. X, we'll call it negative XY. Doesn't this triangle right here have that same negative XY point? But now this angle is obtuse, correct? So we do 180 minus 64.8. That would give us our obtuse angle. 115 point, you said 2? Yeah. So everybody see. So you'll just take 180 minus the acute angle. Find the obtuse angle. Reference angles. Okay. Sweet. And now we can finish solving it using the law of sine. So now we can find this, if we know this angle, and we know that angle, we know that angle, and then we'll use the law of sine to finish solving, right, everybody? Okay. So same thing here. We know that that is 20.5. We can continue solving, but I don't know if we really need to. Because I think you guys get it. Okay, number 6 out of the book says, does the triangle exist? You find out and tell me. Go. So your first thing you kind of draw is something like this. This is where I started out. I drew in a line. We're going to see if it does exist. If so, then we can connect it. So first of all, you found this, correct? What did you get? 8.6. So isn't this going to come down, since it's longer than the height, cross once, cross twice? Because it's shorter than that side, right? So we're going to have, let's draw on the two triangles we have, that one, there where it connected, and there where it connected, and also our obtuse one. So now my next question for you is, what is the acute B? What's the obtuse B? We're calling this angle B. Ready, go. You figure it out. So, you got 74.2. So is that the acute angle? Well, yeah, because we know that our calculator is always going to give us the acute answer, right? Outputs for sine inverse are always between negative 90 and positive 90. So 74.2 goes there. So you'll take 180 minus that, and it will give you obtuse B. I'm going to write it over here. 105.8. Now you could continue solving it. I just wanted to make sure that you could get acute angle, obtuse angle, and that if you knew if it existed. Okay, do this one. Does the triangle exist? If so, how many? So have we figured it out? What is it? One right triangle. Way to go. You figured out the height was 5, right? So this is the same length as this, so it's crossing right there, creating a 90-degree triangle. Way to go. Okay, so last thing to learn today. So now you guys understand that if basically they say solve the triangle, just make sure, check those things. Do I have 2 triangles? Do I have 1? Do I have none? Does that make sense, everybody? Okay, now it says, okay, so to find the area of an oblique triangle, we know how to find area of a right triangle, but there's lots of non-right triangles that you need to be able to find the area of. So area of an oblique triangle is this formula. So 1/2 times B times C times sine of angle A. So that's how you find the area. And if you're interested, there's a proof for it and how they got that on page 434. So area of a right triangle, I just want to remind you, is 1/2 times base times height, right? Okay, perfect. So now we're dealing with non-right triangles. So you'll do 1/2 times side B times side C times by sine of angle A. So I don't love that formula only because people get too caught up in what it's saying. So understand. So it's 1/2 times side 1 times side 2 times by sine of the angle between those sides. So you have to be given a side, and side 1, side 2, and then an angle between. It has to be the angle between to be able to find the area. So that's how I think of the area formula for a non-right triangle. 1/2 times side 1 times side 2 times by sine of the angle in between those two. And once again, if you're interested in why or how that works, or if you want to prove it yourself, go through and do it. Drop an altitude, set up some truth statements, and I guarantee that if you can come up with it. Okay, here we go. Find the area. So first of all, check side 1, side 2, angle in between. Yes. So area is equal to 1/2 times side 1 times side 2 times by sine of the angle in between. Literally, just type it into your calculator. Area of this triangle is... Huh. 2. I didn't remember getting that, but okay. Yeah, you got it? Hey, I just probably don't remember. Now, if I was being like technically correct, if this was a centimeter and this was a centimeter, you multiply a centimeter and a centimeter, then it would be square centimeters. Does that make sense, everybody? That doesn't affect your calculation, but okay, last example. Please stay with me. Find the area. So can we just go about doing this? No, because we're not given the angle in between those sides. So we don't have angle star. So couldn't we find angle star? Let's figure out how we could go about solving. So we're given an angle in 2 sides where the side across from it is larger than the other side. So won't there be this exact one triangle? Yes, okay. So now we could find this angle, I'm going to call it smiley face. We could find angle smiley face using the law of sines. Why do I have to find angle smiley face? Because that's the given side, right? So we would say sine of smiley face over 3 equals sine of 25 over 10. Solve for smiley face. Okay, 7.3 degrees is smiley face. So now that we know smiley face is 7.3 degrees, what star? 180 minus 25 minus 7.3. 120, 140, 7.7. Okay, now we know that this is 147.7 degrees. We can now find area. So we have to do a little bit of work. 1/2 times side 1, which is 3, times side 2, which is 10, times my sine of the angle in between. Roughly 8. Okay, good. Pretty easy. Okay. Cool. So go to page 436. You're doing 1 through 7 odds, 13, 17 through 25 odds. And then those.